All right, so like I said, we are going to be working with inequalities. For those of us that are very good with solving equations, today's not going to be a great big leap from there, okay? Because it's going to be pretty much the same thing. Now, if you struggle with equations, then you're probably also going to struggle with our inequalities. So let's go ahead and get started here. First of all, you notice up at the top it says that inequalities are solved for x using the same steps as equations. The same steps as equations. So this is why I said if you can solve equations, you can solve inequalities. Notice the first thing, step number 1 over here, is to clear your parentheses with distributive property. Just like we do with equations, we use distributive property first. Second thing, step 2, combine variables or combine like terms. 3, add or subtract. Add or subtract. Step 4, multiply or divide. By the way, we need to put a star by number 4 here. Because if we read a little closer there, it says that when you're multiplying or dividing by a negative number, we have to flip the inequality sign. So I need you to underline this for me right here. It's going to be very important here in a second. As a matter of fact, that's the only difference between working with equations and inequalities. Underline that for me.
Put a sign to it?
Yep. 5, what we're going to be doing is writing the answer in 2 different ways. And one of the ways is like this, and another way is using a graph. And I'll show you how both of those work here in a minute. Now notice here when we write the inequality, we want to go ahead and have the x on the left side of that inequality. So for some reason it's on the right, we're going to fix it so that it's on the left. Down at the bottom it says solutions can be written verbal, symbolically, and graphically, which is what I just mentioned, and I'll show you examples of those here in a second. And then it says you can also justify your answers by testing a value. All right, so let's go ahead and take a look at some examples here. The first one, the verbal. X is less than 2. What does x is less than 2 look like? Well, here's what it looks like symbolically. Notice this right here. This is the less than symbol. That right there says x is less than 2. We can also show that graphically with this over here. 2, circle, with an arrow pointing to the left. Now, you guys have worked with number lines before. You guys have seen something that looks like this, haven't you? All right, so that is called the number line. What we have here on that number line, of course, is a lot of numbers. In this case, 2 is right here, so we circle it. That's where we start at. And because we want x values that are less than 2, you guys know that everything to the left would be a number that's less than a 2, which is why we draw or graph in such a way. Okay, so we start at 2, circle it, and point to the left. Because to the left is where all the values are less than a 2.
So that's how it is? Or?
That, and yeah, we're going to work with several examples here. Now notice the second one here says x is less than or equal to 2. So this right here, that right there is called the less than or equal to symbol. And you'll notice the only difference between the first graph and this other graph is the fact that the circle is colored in. And the reason we're coloring in the circle is what? What do you notice about the inequality symbol here? What's the only difference between these two? The equal. So the only time we're going to color in the circle is when we have the equal, which means we're going to include that point, which we'll talk a little more about in a minute. The other is x is greater than 2. So this thing right here is the greater than symbol. Again, the graph of that would be circling the 2, pointing to the right, because all the numbers to the right are greater than a 2. And then the last one says x is greater than or equal to a 2. So that right there is the symbol for greater than or equal to. Once again, notice the only difference is that this circle is filled in. And why are we filling that circle in again? What's the only difference between this sign and this sign? It has a equal sign. So anytime you see that equal sign, what are we going to do to the circles? We're going to color them in. That's the only time we're going to do it. We see that equal sign.
But whenever we see equal sign, we color it in.
Color it in. Yeah, and I'm going to show you some more examples. Now, there are a couple of special cases that we're going to come across. One of those special cases is all real numbers. Right here, all real numbers. And the symbol we use for all real numbers is an R. And the way we show all real numbers graphically is a line that goes in both directions. And when we say all real numbers, basically what we're saying is every number that's on the number line, every positive number and every negative number, which is why we draw the line like that with two arrows pointing in each direction. The other special case is a no solution. And the symbol we use for no solution is this thing right here. That's no solution. Now in this case, there is no graph for this one. In other words, there are no numbers on the number line to represent a no solution. So these are two special cases. So what we're going to do is we're going to take a look at a couple of examples. And I'm going to be very basic here, guys. There's an algebraic method, and they ask us to justify it by graphing and tables. We're going to stick to algebraic here. So the first thing I need to do is go ahead and write down the problem. Now I suggest if you have some map colors, colored pins, you might want to pull those out so we can show each step along the way in a different color. What we're going to do is we're going to treat these inequalities exactly the same way we did with our equations. So what I'm saying is just pretend that that less than symbol right there, just pretend that it's an equal sign. Just do the same thing we did earlier this week. So here we go. I'm getting ready to do the first step here. And that first step is to do distributive properties. So we're going to take this 2 and multiply it with the other 2. 2 times 2 is going to give you a 4. Take that same 2, but this time multiply it with a negative x. 2 times a negative x is a negative
2x.
2x. So all I did was distributive property. All I'm doing is bringing down that x minus 2 on the other side. So that is my first step. That right there is distributive property. The next step is to combine like terms. So what I want you to do is look at just the left side. Look at this side right here, 4 minus 2x. Are those like terms? Can I put those two together?
No.
No. Look at the right side over here, x minus 2. Can I put those two numbers together?
Yes.
No.
No. One has an x, the other doesn't. Those aren't like terms. But what I do see is an x on the left, and I also see an x on the right. So what I'm going to do is I'm going to get all the x's so they're on the same side. So what I'm going to do is I'm going to take this x, and I'm going to move it over here with that minus 2x. So here we go. The opposite of a positive x is a negative x, or a minus x. So I'm going to put another one here, because remember, whatever we do to one side, you also have to do it to the other side. So these x's are gone. They're no longer there. All I have is that. Well, let me hold off on that. Here's where some of us are messing this up. We got a negative 2. We're going to put it together with this negative 1x. So that negative 2x and that negative 1x, when you put those two guys together, what are you going to get? What's that?
Negative 3.
Negative 3. That now becomes a negative
3x.
We're putting them together. Well, no, we're not multiplying them, we're adding them
It's only
together.
multiply.
That's right. When we multiply is when you get a positive. So what I've done is I've taken the x's and put them together. You'll notice that that 4 and this minus 2, those guys can also go together. So that's what I'm going to do next. I'm going to combine those two numbers together. Here's the catch. Here's the catch. Here's the catch. Since I have x's over here on the left, I'm going to put the numbers that don't have x's on them on the right. You've got to keep those guys separated. They don't get along very well. So we're going to take these 4 and we're going to move them over here. And I'm going to do that by subtracting it. So if I subtract it from the left, then I also have to subtract it from the right. So this 4 minus this 4 is let's see, we're going to put those two guys together. You got a -2 and a -4.
-6.
What do you get when you put those two guys together? A
-6.
-6. Remember, we're adding those two numbers. So now we're at a point where we have -3x is less than a -6. You're almost there. Almost. Let's get a different color now. Show our step in a different color. It's our last step. Right now they're taking x and they're multiplying it by -3. So what I'm going to do is the opposite. I'm going to divide by a -3. Make sure you divide both sides by -3. This way, we have x by itself. That -6 divided by that -3. What's a -6 divided by -3? Positive what? Positive 2. Positive 2. By the way, notice I have not brought down my inequality symbol. Here's why. In our notes, a second ago we talked about this. Matter of fact, I think I even had you underline. Step number 4, when we multiply or divide, it said that when you multiply or divide by a negative number, that you must flip the inequality sign. When you multiply or divide by a negative number, flip the inequality
So
sign.
leave less than.
So, let me go back to that problem. Here it is.
X is greater than
Notice
2.
what I did. I divided by -3. So what I'm going to do, because I divided by that -3, is flip the sign around. So it's no longer less than, now it's
Greater than.
greater than. So what I have here is that x is greater than a positive 2. X is greater than a positive 2. Now that's one way to write the answer. It's not the only way, but it is one way. I said another way you could do this is on the number line. Show it graphically. So that's what we're going to do next. So what I want you to do is draw me a number line. Now on this number line, I'm not expecting you to put all the numbers. I'm not expecting a 0, 1, 2, 3, 4, 5. That's not what I'm expecting. But I do have a number line. There is one particular number that I want to see on the number line. And that number is going to be a
2.
2. Whatever number I have here is the number I want to put on my number line. And I'm going to go ahead and put it in the middle. Just understand that everything to the right
It's positive.
is positive. What number would be after 2?
3.
3, then a 4, then a 5, 6, 7.
So on.
What number would be in front of the 2?
1.
1, 0, -1, and so on. Okay? So just keep that in the back of your mind. So here's what we're going to do. We're going to start by circling the 2. That's our starting point. So circle it. I'm not going to color it in though, because the only time I need to color it in is when I have a
Equal to.
equal sign. And right now I don't have it. So don't worry about coloring it in right now. Now notice it says that x is greater than 2. So what side has numbers that are greater than the 2? The side over here to the right, or the numbers to the left? Where are they bigger than a 2?
Right.
To the right. So what I'm going to do is I'm going to draw an arrow to the right. That's because that's where all the numbers are greater than a positive 2. For example, a 3, 4, 5, 6, and so on. So this is one way to write it, and here's another one, graphic. All right, there's the first one. Second one, number 2, 5x plus 4 is less than a -6. We're going to get lucky on this one because there's no parentheses, so there's no need to go through distributive problems. Don't need to worry about that step. Matter of fact, you can also see that there's no like terms I have to worry about. There's nothing over here on the left I can put together, and there's nothing over here on the right that I can put together. So I'm going to go ahead and move on to the next step, which is to either add or subtract. What's the opposite of adding a 4?
Subtract the 4.
Subtracting a 4.
But you have to do it to both sides.
All right, that's right. We have to do it to both sides. So that's gone. Remember, guys, we're putting these two together. So you're taking the -6 and the -4, putting them together. So what do you get when you add those two numbers together?
Hold on.
-6 plus a -4.
Negative 10.
-10. just did the first step. You subtracted 4. You're almost there. You got one other thing to do. Right now they're multiplying it by 5. So what's the opposite of multiplying it by 5?
Divide.
Divided by 5. This way we have the x by itself. You have a negative 10 divided by a positive 5.
Equals
That's going to leave you with a
negative 2.
negative 2. Now here was the rule. The rule said if you divide by a negative number, wait, if you divide by a negative number, you got to switch the sign. What number did I divide by? 5. That's a positive 5. So do I need to flip the sign on this one?
No.
No. Don't flip the sign. It's only when you're dividing by a negative number.
Only when you divide or you
Multiply or divide. It could be either one. Multiply or divide. So again, this is one way to write the answer. That's one way. But I also want to see the graph of this. So let's take a look at the graph. Here's my number line. You don't have to write all the numbers down. That's okay.
Just write the number.
But I do want to see one number. In this case, the number I want to see is negative 2. What I'm going to do is I'm going to circle negative 2. And then what I'm going to do is point in one direction. I'm either going to point to the left or I'm going to point to the right. And that depends on what it says. In this case, it says that x is less than a negative 2. So what side has numbers that are less than a negative 2? To the left or to the right? To the left. So what we're going to do is we're going to point to the left. So this is what it looks like graphically. By the way, guys, if you're really paying attention to that sign there, everybody look right here real quick. Look at that inequality sign. It's actually telling you which direction to point. It's telling you to point to the left.
Cool.
If you see that symbol,
Point to the right.
it's telling you to point to the right. So just look at this. Now that is, of course, as long as the x is on the left side, which it should be. So that's what I'm asking you to do. Make sure the x is on the left. Okay? So just look at the sign. It'll tell you where to point.
If you're right.
Of course, if you're right. 3. Number 3. Notice on number 3 here, this time we do have some parentheses. So the first thing we're going to have to do is get rid of those parentheses. So we're going to start off with some distributive property. 6 times the x. 6 times the x is going to give you a 6x. Take that same 6, multiply it with your 2. 6 times 2 gives you 12. Bring down everything else. Bring down the minus 4x. Bring down the 8. There's your first step. Then I'm going to go on to step 2. So I'm going to use a different color here. I'm looking on the left side. Looking at the left. 2 of those you can put together. Anybody know what 2 I'm going to put together?
Negative 4x and
The 6x and the
negative 4x.
minus 4x. So look what it says. We've got 6 x's. They want you to take away 4 of them. So 6 minus 4 gives you 2. 2x. I'm going to bring down that plus 12. And I'm going to bring down my 8. There's step 2. Combine the like terms. Now moving on to the next step, which is the opposite of adding 12. And the opposite of adding a 12 is to subtract the 12. So this is gone. I need some help here. 8 minus the 12. That in your calculator. What's 8
Negative 4.
minus the 12? Negative 4. Thing is getting smaller, which means we're getting closer. All I've got to do now is take the 2 and do what with it? Divided by 2. So a negative 4 divided by a positive 2 is going to give me a negative 2. By the way, look at what you divided by. What number did you divide by?
2.
A positive 2. So do I need to flip the sign if I'm dividing by a positive 2?
No.
No. So just leave that sign alone. So here's one way to write the answer. X is greater than or equal to a -2. Now what I'm going to do is show that thing on the number line. So there's the number line. -2 is the number I'm going to put on the number line. I'm going to circle.
Colored
that
in.
negative
Colored
2.
in.
Why are we coloring this one?
Because it says equal.
That's right. This one says equal, so we're going to color it in to
gonna
show
point
that
to
we
the
want to
right.
include it. And which way am I going to point
To
it?
the right.
To the right, because all of these numbers are greater than a -2. And it also tells you right there to point to the
Right.
right. So this is number 3. Okay, number 4. Do me a favor. Don't worry about this. Go ahead and scratch that out so it doesn't confuse you. Don't worry about that. Right now we're just looking at the inequality. That's what we're working with. Notice we have 2 sets of parentheses, so I'm going to have to do distributive property twice. Let's start right here. 5 times 9. 5 times 9 will give you how much?
45.
45. Take that same 5, but multiply it with your minus x.
5x.
5 times minus x is a minus
10.
5x. So you just got rid of one of the parentheses. Do the same thing on the other side. Take the 4
4x.
and distribute. 4 times x gives you
4x.
4x.
72.
4 times 18. What do you get when you multiply 4
72.
times 18? What was that?
72.
72. So there's the first step, distributive property. Well, let me take a look at each side. Let me look at the left side. Can I put those two together on the left?
No.
No. What about these two over here on the right? Can I
No.
put those two guys together? No. But what I can do is, I've got some x's on the left, I got some x's on the right. So what I'm going to do is go ahead and get them all on the same side. So I'm going to take the 4x's and I'm going to move them to the left. So here we go. We're going to subtract. So those 4x's minus these 4x's, that means that's gone.
No.
Let's take a look over here. We're putting these two guys together. We're adding. So the negative 5x and the negative 4x, when you add those together, now what you're going to get is a, how much? Negative 9. You're adding them together. Negative 5 plus a negative 4. Now while I'm here, I'm going to also move that 45 over with the 72. So how do I move the 45 over here with the 72? We're going to subtract. Try to think opposite. 45 minus 45, those are opposites. They're gone. But I need some help here. That's 72 minus 45. What do you get when you subtract 72 minus 45? What's that?
27.
27. There we have step 2. We're almost there. What's the last thing I'm going to do on this thing?
Divided by 9.
Divided by
Negative 9.
negative 9. So 27 divided by negative 9 will leave you with
Negative 3.
negative 3. Look at the number you divided by. Notice that number is a negative 9. Do we need to flip the sign on this case?
Yes.
Yeah.
Yes. Flip the sign because we're dividing by a negative number.
I don't get that. Look what?
What's that? When to flip it?
Yeah.
This bottom number here, when that bottom number is a negative number, you're going to flip it. Because you're dividing by.
So the only time you ever flip it is only if it's negative?
It's not
If
like
it's
It's a negative, but
When
it's
you're
multiplied
multiplying or dividing. Right now, all we've done is divide. But that could also be the case where we.
So what if you have a negative 27 and a regular 9?
Good question. What if we had this right here? Negative 27 divided by
Could you
5.
switch it with you?
Would you flip it in this case?
No.
No. Like I said, it's got to be the bottom number that's a
What
negative.
is divided by?
Whatever you divide it by. All right, let's go ahead and finish this up so we can see its graph. Here's the number line. The number I need on that number line is a
-3.
-3. We're going to circle it.
Color it in. Go to the right.
Color it in because it has the equal sign, so we want to include the point. And because I want the numbers that are greater
Go to
than
the right.
-3, we're going to point to the
Right.
right. So everything to the right is greater than a -3. Bigger. That's number 4.
Because it's about to be like
Special case. We're going to do one more here, and then we need to start our test. Special case.
Those pretty goes by fast. Right?
Here's what we have. Something weird's going to happen on this one. You'll notice that we got x's on both sides. So what I'm going to do is get all the x's on one side. So what I'm going to do is take the 4 x's and move them to the left. So I'm going to subtract. Now look what's going to happen here. 4 x's minus 4 x's gone. But I still have that -7. But here's what I mean when I say something weird happens. What happens on this side? What's 4 x's minus 4 x's? 0. So do you have any more x's? No. You have nothing on this side. Absolutely nothing. What number do we use for nothing? 0. I want you to look here. First thing you notice is there's no more x in the problem. That's the first thing you notice. Second thing you notice is what it says here. It's saying that 0 is less than or equal to a -7. Is that true? Is 0 smaller than a -7?
No.
No. That is false. Write down that that's false. And what happens is anytime we have a false statement, we say that there is no solution. There are no answers to this thing up here. So the symbol we use for no solution, and it's in our notes, is a 0 with a line through it. So there are no answers to this problem here. There's no solution. No solution.
Is that it?
All right, we got about 10 minutes, so we need to get started on our test here.
Well, pretty